All right. So let's first start with the concept of area. So what is the area of this region in the coordinate plane? So you have, this is a rectangle. So the height is basically given by 3 and the width is given by 2. So since it's a rectangle, area is going to be 2 times 3, which is going to be 6. Okay. Now let's look at the following. So find the area of region in the coordinate plane bounded by x-axis and line y equals to 2x and x equals to 3. Now this turns out to be a triangle. Now to find the area of triangle, we need to find out the length of the base. So the base is basically 3. And what is the height? For height, we need to compute this intersection. So when do they intersect? When these two, you have to solve these two together. And solving these two together means substituting x equals to 3. So you get y equals to 6. So this thing is going to be 6, the y value. And the area in this case is going to be half times base, which is 3. And the height is basically 6. And that is going to be 9 square units. Okay. Now let's ask the next question. Find the area of the region in the coordinate plane bounded by x-axis. So this is your x-axis, bounded by line y equals to x square. So this is a curve, y equals to x square. And then line x equals to 3. So what is bounded by all these three is this region here. And then the question is, what is the area? Area of this region. Okay. Now we know the area of rectangle and triangle, but in this case, we do not know the area of it yet. So what we'll do is we'll try to do some kind of an approximation first to find out the area. Okay, so let's look at the following. The same problem, I have expanded it now a bit. Again, the goal is to estimate the area of the region of the coordinate plane bounded by x-axis, which is this axis here. And what? Y equals to x square, which is this blue line here, and x equals to 3, which is going to be. So we want to find out the area, which is basically this part here, right? We need to find out what is this area. Okay, so how do we go about it? So we need to find out this area. What we'll do is we'll try, since we know the area of rectangle, we'll try to approximate it by some kind of rectangles. So let's try to make 3 rectangles here. Now for rectangles, we need some height. So let this be the height. So we are choosing, this is the height, and then this has a height. So now what is the area of this rectangle, area of this 3 rectangles? So first one is going to be what? The base area is, sorry, the length of the base is 1. What is the height in this case? So height is going to be, so height is given by the function value at 1. So this is going to be 1 times 1 square. Then the second one is what? Going to be what? 2 times, sorry, 1 times the width, the base is again fixed of length 1, and the height is going to be function value at 2, which is going to be 2 square. Then again 1 times the function value at 3, which is going to be 3 square. So if you simplify this, is going to be 1 plus 4 plus 9, which is 14 square units. Now again, this is clearly an overestimate, right? This area of these triangles, if you look at the area of triangles, this triangles area is clearly bigger than the area of the curve. Yeah. So this is, nevertheless, this is an estimate. It's not a proper estimate, but it's an estimate after all. So let's try to see the following in the following form. So I'm doing the same thing here. Now I am basically taking n equals to 3, n equals to 3, and we got, like, in our computation, we got area to be, some of these rectangle areas to be 13. Now, what if we start increasing the number of rectangles? So if we have more and more rectangles, you can see the area is getting more and more refined, or the area of rectangles is getting very close to the area under the curve, right? As you see, keep on making bigger and bigger rectangles, you see the area is getting very close to the actual area under the curve. So area of the sum of the rectangles turns out to be very close to the area under the curve, right? So, the more the number of rectangles you have, the better approximation of area you will get. It seems, at least from this graph, right? This GeoGebra thing. Do you agree with that? So now let's move ahead and try to do the same thing here. What we'll do is we'll have, instead of 3 rectangles, we'll have more than 3 rectangles and see what do we get an estimate for the area. So again, I'll draw the same thing. So I'm going to draw the same thing now. I'm going to have 1, 2, 3, and I will draw this curve like that. So what we'll do is the following. So again, 5 and 10. So we will, instead of having, so instead of having 3 rectangles, we will basically divide into smaller parts. So we'll divide it into n rectangles. So we'll take what? We'll take 0 to 3, and we'll divide into n rectangles. So n rectangles. So what is the size of each rectangle then? So divide 0 to 3 into n parts. So what do we get in that case? The width of each of this guy is going to be how much? Let's call each of this as delta x. So width is going to be equals to delta x. That is the name we are giving it, and it's going to be 3 minus 0 by n, which is going to be 3 by n. Okay, so that is the width of each guy. And now we are choosing the right hand for the height. So for this rectangle here, we'll choose the right hand point for the height. So we are choosing the right hand value for the height. So what is the value of this guy? So the height is going to be, so you divided this guy into, this is divided into 0 equals to x0, then x1 less than xn equals to 3. All right. Now, so what is the height of this guy? So let's see, what is the height of the first one? So for the first one, the base is delta x, like every each of this triangle, delta x. And the height is going to be what? The value of function at this point. What is the first point? The first point is going to be 3 by n. So what is the height at that point? The height is going to be the value of function, which is y equals to x squared. So we get 3 by n, the whole square. Let me erase this. I know what is delta x, so let me write it as 3 by n. Now what about the next one? So for the next height, for the next rectangle, my bad, the height is going to, base is going to be fixed, which is 3 by n. And the height is going to be the value of function at this point. So what is the value of the function at this point? Is going to be 3 by n times 2 the whole square. Yeah, which is 6 by n. Now let's go to the next one here. For the next one, again, the base is fixed, 3 by n. What is the height in that case? Height is going to be 3 by n times 3, the whole square, and so on and so forth. So you keep on doing it until the last one. So you make all these rectangles, right? Yeah, and then you're basically finding area of all these rectangles and adding them up. Yeah, and the height of the last one is going to be 3 by n times 3 by n times n, the whole square. All right. So such a sum, let's call it as Rn. So you're using the right hand points, the value of the function at the right hand point for the height. You can also call it right hand Riemann sum if you want, or right Riemann sum if you want. Now let's rearrange this slightly. So if you rearrange this, this looks like, if I take 3 by n common from all of them, I get what? 3 by n square, which is going to be, well, I can take 3 by n square common from each one of them. What is left here? So you can think about here as 1. So you get 1 square. Then here you have what? 2 square. Here you have what? 3 square. Then so on all the way until n square. Right? So we need a formula for, so this is going to be 27 by n cube times what? Summation 1 square plus 2 square plus 3 square plus 4 square and square. So do we know a formula for this? 1 square plus 2 square plus 3 square all the way until n square. The formula for that is what? N into what? N plus 1 divided by, multiplied by 2n plus 1, the whole thing divided by 6. Okay, so this is your Rn. Now note that still this area of these rectangles when added up is bigger than the actual area. So the actual area of the curve, so area under the curve is going to be what? You take a limit of this as n goes to infinity, and then you will get an actual area, right? So limit as n goes to infinity of Rn. So this is going to be limit as n goes to infinity of 27 by 6. Now there are n cube. I'll distribute them, each of the n to each of the terms. So n by n plus 1 divided by n, 2n plus 1 divided by 6. So you can cancel these guys off. You will get basically limit of, you can write this as 1 plus 1 by n, and you can write this as 2 plus 1 by n, right? And now as n goes to infinity, 1 over n goes to 0. So you will get, this is 27 by 6 times, here you will get 1 times 2, which is going to be 27 by 3, which is 9 square units. So note that when we saw this thing on GeoGebra, yeah, you see the answer was very close to 9.1694, right? And this is not even going to infinity. This is only going for 80 rectangles. Yeah. So the more rectangles you have, the better approximation you will get. All right. So now here we used what? The right hand point for the, we use the right hand point for the height. Now you can do the same thing with the left hand point. So we already showed that limit as n goes to infinity of Rn is 9. Now let's do the same thing with Ln. So what is the idea? Again, let's draw the function. So we have 1, 2, 3, 1, 2, 3. We have a graph like that. Okay. And we want to find out area below this curve. So what we'll do is instead of we'll divide it into, first of all, into n pieces like that. Yeah. N pieces. So each piece is going to be, so if you look at each of this rectangle, sorry, you have the base of the rectangle again, delta x. So base of rectangle is delta x, which is again going to be what? B minus a over n, right? 3 minus 0 over n, which is 3 by n. Now what is the height going to be? So instead of choosing so in this piece, instead of choosing the right hand point for the height, we'll choose the left hand point for the height. So here the height is 0. So the first rectangle has basically area 0. So it's going to be 3 by n is the base, and the height is given by, height is simply what? 0 square, because the value of the function at 0 is this. Now let's look at the next point. So the next point is going to be 3 by n, right? So the base is 3 by n, and the height is going to be 3 by n square. Then what about the next one? Next one is going to be, base is going to be, for the rectangle, is going to be 3 by n, and the height is going to be what? 3 by n times 2, the whole square. And all the way until, for the last one, so you see you're basically using these guys now. For the last one, the height is going to be what? So the base is going to be 3 by n, and the height is going to be 3 by n. Instead of n, it will be n minus 1, the whole square. Okay. So this is the area when you use the left hand point for the height. So now let's see, let's simplify this. So this can be written as 3 by n in bracket, again another 3 by n, the whole square outside common, times what? First one is 0 square, then the next one is 1 square, then 2 square, all the way until n minus 1 square. So you can take this guy out, you get 27 by n cube. We have 0 square plus 1 square plus blah blah n minus 1 square. Do you know a formula for this? This is same as the summation I square formula, but with what? N minus 1. So this is going to be what? N minus 1 into n into 2 times n minus 1 plus 1 divided by 6. So this is going to be 27 by n cube. Sorry, 27 by n cube, yeah. N minus 1 times n times 2n minus 1 divided by 6. So this is your area when you take the left hand points for the height. It's an underestimate, but still, let's see what do we get. We get, in this case, if you take limit as n goes to infinity, you will get, as you saw, the more number of rectangles you take, the better approximation you get to the area of ln is going to be limit as n goes to infinity, 27 by 6, n minus 1 by n by n times 2n minus 1 by n. Now this can be seen as, this can cancel out. You will have 1 upon 1 minus n, and here you will have 2 minus 1 by n. Now limit as n goes to infinity of that is 27 by 6 times 1 times 2 minus 0, so 2, and that is going to be 9 square units. So you see, whether you took the left hand point and the right hand point, the limits are going to be the same. So So these are the formulas you need to know. First formula is if you have 1 plus 1 plus 1 plus 1, 1 n times. If you add 1 n times, what do you get? N. Yeah. Now this can be written in short as summation I going from 1 to n of 1. This is n. Okay. So this means that you keep adding 1 until I is 1, then I is 2, you have 1, so on and so forth. Now summation, now similarly you have 1 plus 2 plus 3 plus 4 all the way until n. Now this is written as summation I going from 1 to n of I. And this sum is given by n into plus 1 divided by 2. Okay. And the next one is you have 1 square plus 2 square plus 3 square plus 4 square all the way until n square. Now this formula is given by n into n plus 1 times 2n plus 1 divided by 6. And another one is 1 cube plus 2 cube blah 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 until n cube. That is given by n into n plus 1 divided by 2 the whole square. Okay, and if I want to write this in the summation form, I should write it as I going from 1 to n of I cube, and this I should write summation I going from 1 to n of I square. So we want to generalize the concept what we did earlier of finding the area using rectangles. So we have a continuous function on interval a to b. We divide this length from a to b, into n equal parts. So let's divide this into n equal parts. So each part will be of width what? Each part will be of width b minus a over n. That is your delta x. Now, since you saw that if you take the right hand or the left hand, the answers are same. So we'll choose to use the right hand points to find out the what? To find out the areas of the each rectangle. So now, so you divide, basically you're dividing a to b into n equal parts. So first part is going to be what? So this distance, this length is delta x. So first point, which is x0, that is going to be a. But the second point is going to be x1, which is going to be a plus delta x, right? Which is here. Then the third point is going to be this delta x plus this delta x plus a. So x2 is going to be a plus 2 delta x. Similarly, x3 is going to be a plus 3 delta x, dot, 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 all the way until n. xn is going to be a plus n delta x, which is your b. Now, let's find out what is the height of this. So what is the total area of the rectangles? So for the first one, the base is going to be delta x, which is delta x. And the height is given by the function value f of, so if this is x1, this point is x1, let me mark it with an arrow, then this height is given by f of xn, right? F of x1. So this height is given by f of x1. So that is the first one. For the second rectangle, again, the base is delta x, but the height is given by the function value at x2. So this is given by, the height is given by f of x2. Yeah. So you get f of xn, x2 times delta x, and so on, so forth, f of xn delta x. So this is your Rn. Now, if you want to write it in the summation form, we can write it as summation I going from where to where? I goes from 1 to n f of xi delta x. And this is your Rn. And then we said, because the the left-hand sum and the right-hand sum did not really matter, as we saw in the earlier case, it is true in general if the function is continuous, we will define the area to be limit as n goes to infinity of Rn, which is this guy here. Okay, so for that we need that what the area of region. So let's reread this. Area A of the region S that lies under the graph of continuous function f on over an interval AB. So you have this function f of x. This is continuous, as you can see, over interval AB, and you want the area below this shape, this graph. It is given by limit as n goes to infinity of Rn, which is this limit. And then in sigma notation, which is a summation notation, it's more compact. That's why we are using it, is limit then goes to infinity of summation I going from 1 to n f of xi delta x. So this is how this one goes. So let's do a problem now. Find the area under the graph f of x equals to 100 minus 3x squared from x equals to 1 to x equals to 5. So we have here our delta x is basically b minus a over n. So 5 minus 1 over n, which is 4 by n. Now we are using this as a form here. So what is my f of xi? So xi is basically what? 1 plus delta x times I, which is going to be 1 plus 4 by n times I. So now what is my area? Area is going to be A equals to limit as n goes to infinity, summation I going from 1 to n, f of xi, so f of 1 plus 4 by n times I multiplied by delta x, which is 4 by n. Now you see whatever does not has I in it can be taken out. So this can be written as limit as n goes to infinity. 4 by n is common, so I'll keep, well, I can take 4 by n outside the limit. Now summation I going from 1 to n, 1 plus 4 by ni. What is f of that? That is going to be 100 minus 3 times, instead of x, I have 1 plus 4 by n I the whole square. Now this is same as limit as n goes to infinity, summation I going from 1 to n, 100 minus, let's expand this. So 3 times 1 plus, so a plus b the whole square is a square plus 2ab, so which is going to be 8 by ni plus b square, which is going to be 4 square, which is 16 by n square times I square. And now I'll simplify this a bit. So this is going to be, and we forgot about 4 by n. Let's keep that 4 by n here. So this is going to be limit as n goes to infinity, 4 by n, summation I going from 1 to n, 100 minus 3 is going to be what? 100 minus 3 is going to be 97. Now 3 times 8, so I'll break the summation and give summation to everyone. So 3 times 8 is 24 by n then summation I going from 1 to n of I. Minus again, because this minus sign from outside will make all of them minus. So 3 times 16 is 6 times 8. 6 8s are 48. So 48 by n square times summation I going from 1 to n of I square. Now we need to use the formulas for each of these guys. So limit as n goes to infinity, 4 by n. Now what is the formula for this? Summation 97. So you're adding 97 n times. So this is going to be 97n. This one will be 24 by n times, what is summation I going from 1 to n of I? N into n plus 1 divided by 2 minus 48 by n square. And what is the summation formula for I going from 1 to n of I square? N into n plus 1 times 2n plus 1 divided by 6. Okay, so now we have to take this limit. So let me bring this 4 by n inside. So when I bring 4 by n inside, I have to multiply it with every one. So the first one will be 4 times 97, right? Or if you want n, I'll write down n's as well. So I can have n divided by n. This is going to be what? 24 by 2 times 1n will cancel with this guy. We'll have n plus 1 divided by n. For this guy, we'll have 48 by 6. I am taking constants together. There is n square here. So one n will cancel with this. Other n will come below this guy. And the outside n will come and multiply. So we'll get 2n plus 1 divided by n. And we have to multiply this by 4, right? So this is multiplied by 4. This is also multiplied by the 4, which was outside, had to multiply with all of them. So now we need to simplify this. So this will go away with this. This will become 1 plus 1 by n. This will become 1 plus 1 by n. This will become 2 plus 1 by n. Now limit as n goes to infinity of 1 over n is 0. So we'll be left out with 4 times 97 minus 24 times 2. Sorry, 24 times 4 divided by 2, which is going to be 48. Here will be left out 6 8s are 48. So 8 times 4. So 8 times 4 is what? 4 8s are 32. And then multiplied by this 2 here. And then what do we get? We have 4 times 97, which is going to be 400 minus 12. What is 400 minus 12? 388. Minus 48 minus 64. So 48 minus 48 minus 64 is going to be 112. And then you can see when you subtract, you will see that it's going to be 672. So 672 square units. So this is the setup, right? Are there any questions, comments so far? Now, one of the application problems is the following. Find the distance traveled by an object during a certain time period if the velocity of the object is known at all times. Now, you can think about this as a inverse of what? The velocity problem from calculus 1, right? In calc 1, you knew the distance traveled or displacement if you are looking at velocity. So let's look at just velocity. So let V, so S was the distance traveled, and then V was simply ds by dt, right? Now this problem is the inverse of that problem. So inverse of the velocity problem. Namely, here you are given, given velocity, find distance traveled. Now we know that distance is equal to distance upon time is velocity. So distance equals to velocity times time. Right? So if the velocity was a constant, then the life would have been pretty straightforward. You had d equals to velocity times t, and you would have been done. However, if the velocity is changing, it is more tedious, right? It is more involving to find distance traveled. So what we'll do is the following. Let's look at the following graph. So you have, this is your time t, suppose, and you have your velocity, and the velocity graph looks like that because you know the velocity at all the times, right? Because this is what it's saying. You are the velocity of the object is known at all times. So let's look at the following. So we have, suppose this is time t equals to 1, t equals to 2, t equals to 3. So now how would you find out basically? So this is time t equals to, say, t equals to 0. Okay, so maybe it's a good idea to draw the velocity graph like that. Now, so let's try to see what is the distance traveled then. So distance is going to be velocity times time. So this is the time axis, this is the velocity axis. Now suppose the distance traveled, the velocity between t equals to 1 and t equals to 2 can be approximated by some value. Let's say, for example, in this case, we take the left hand height. So this is your velocity. Say you approximate the velocity on the whole interval by this guy. Here, if you approximate the velocity by this guy, and on this interval, you approximate the velocity by this guy. So the distance traveled is going to be what? The distance traveled is going to be, first one is going to be distance from 1 to 2, which is 1 times velocity v1, because v0 in this case, because we are using 0 to approximate the velocity as 0 to approximate the velocity in the whole time interval 0 to 1. So this is going to be 0 to 1. Similarly, distance traveled from 1 to 2 would be approximated again. The time is 1, and we are approximating velocity by the left hand point. So this is going to be v of 1. And then distance from 1 to 2 to 3 is going to be again approximated by 1 is the time, because the time width is fixed and velocity at that is 2. So we are using the left hand point. So the total distance traveled would be roughly 1 times v0 plus 1 times v1 plus 1 times v2. Yeah. In fact, if you want to have an exact estimation of the velocity, we'll do as we did the Riemann sum. So exact distance would be, is going to be, you take the either the left hand sum, in that case is going to be summation I equals to 0 to n minus 1 vi t times delta t, or if you use the right hand one, it's going to be limit as n goes to infinity, summation I going from 1 to n vi of t delta t. So these are the two ways to find out the exact distance traveled. Right? So